Knox Game Design. June 2022. Iframes and Stunlock.
Welcome everyone to Knox Game Design for June 2022. My name is Levi Smith, so this month's presentation is going to be on iframes and Stunlock. So originally this was just going to be about iframes, so I went ahead and added Stunlock as well. So this is something I've never really heard game developers talk much about. But I heard a lot about it in the speedrunning communities when I watched the speed runs. A lot of people talk about iframes and Stunlock. So what are iframes? Typically, I think people refer to these as invincibility frames. I think I've heard some people refer to them as invulnerability frames. But basically what it does is it gives a player a chance if somebody's getting attacked. It gives the player kind of a chance to get away without taking additional damage. And this is really important with game development, especially like 2D games. Like most game developers, when they start out with the 2D game, you'll run into this because you'll have two objects and they collide, and then for every frame you're going to take damage. So there's some ways to resolve this, and some ways to provide visual cues to players whenever they are in this iframe invincibility time period. First is like in the really old NES, Nintendo Entertainment 8-bit games, you'll see the character blinking for a brief period. Later games just use transparency. So the blinking was really a way to like do a transparency just by flashing the character on and off really quickly. Or some games even have custom animations whenever the player is getting hit. So I think that's probably the best thing to do, is have a custom animation. Another thing, I'm not really going to talk about this too much, but knockback whenever a player gets hit during that invincibility period, during the stun lock, they'll get knocked back a little bit. One thing you got to watch out for is when a player gets hit, don't let the player get hit into a wall and get stuck. Something that could possibly happen. So what is Stunlock? So we talked about iframes. What is Stunlock? So Stunlock's a brief period of time when the player can't move. And this really gives the feeling of like, hey, you're really getting hurt by the damage that you just took. So yeah, don't allow the player to move for a brief period of time. I describe this as ghosty. I mean, if you get hit and you can keep moving, it really doesn't feel like you actually got hit. You might show that you've taken damage and your total health, but if you get hit and you keep moving, then in any way that you want, it really doesn't feel like you've been hit. The other thing you got to watch out for, you can make it too short, or you can make the stun lock too long. So if the stun lock is really long, then it's going to feel cheap, like, hey, you're locked into place and I can't move. So don't make it too long. And typically, your stun lock's going to be a fraction of the invincibility time. So you don't want your stun lock to be longer than the invincibility time. That wouldn't make sense. But yeah, just a short amount of stun lock, that might be part of the getting knocked back. You can have stun lock and knockback at the same time. And then give the player a little bit more time to escape. Just with that invincibility time, just a little bit longer than the stun lock time. Yeah, so here's some of the things you got to consider, especially like with the speedrunner types. If you make your iframes and your invincibility too long, then players will intentionally get damaged to skip parts of the level that you want the player to play. So try not to make your iframes too long. Another thing you hear speedrunners frequently talk about is damage boosting, and that's typically like you get hit by an enemy to get knocked further past some other obstacle or some other. That's why I put here getting hit on purpose. So really, when the player gets hit, then you just want to give the player a little bit of time, maybe to escape that enemy, but not escape other enemies in the level. If you make the iframes too short, then the player can get they won't be able to escape. I've seen that in some old NES games. You can just get pinned against a wall, and you won't be able to progress through the level. It's almost like, hey, you're trapped in instant death. Yeah, and you get hit by the same enemy or projectile multiple times if your iframes are too short, which you don't want that. So I spent some time and went out, actually used an emulator, looked at some old NES games. I tried to make this as accurate as possible, but I went through there and took like snippets of characters getting damaged from, let's see here, 6 classic NES games. And I went through there and counted like the frame when the damage started and the frame when the iframe started and the iframes end, took the difference and made this cool chart right here just to give people like a frame of reference on how long your iframes should be, especially like in a 2D platformer style game. So the first game that I looked at was the original Ninja Gaiden, believed by Tecmo, and counted the frames in it. And it had 60 frames. So these old school NES games, at least in the emulators, did 60 frames per second. So that was a perfect 1 second of iframes of invincibility. Then I also went back and looked at the amount of time from when the player was hit and then when the player is able to start moving again. So that's your stun frame. So 32 stun frames, which is a little bit more than a second. Legend of Zelda, and I do have like the cute little grab screenshots whenever the character got hit. It is kind of interesting looking at some of the games like Ninja Gaiden. It does have what appears to be a custom sprite for when players damage. Zelda had no damage custom sprite or anything. As well as Super Mario Brothers. Metroid was very interesting. It actually reused the spin attack sprite for the damage. Castlevania looks like it had a custom sprite, as well as Mega Man 2 had a custom sprite for being damaged. But anyway, back to it. Zelda had 48 iframes. That's 0.8 seconds, a little bit less than a second. Only 8 stun frames for just a little bit more than a tenth of a second, 0.13 seconds. Mario Brothers. So Mario Brothers had a really long invincibility time. It had 214 frames of invincibility for 3.56 seconds. So over 3 seconds of invincibility. Stun frames was 55 for almost a second, 0.92 seconds. But the one thing to mention about the original Super Mario Brothers, Super Mario 1, is that the whole game froze basically whenever you got hit. So that you got to take that in consideration. If that didn't happen, then maybe the time would have been a little bit less, because you can't just like start skipping over stuff because you're totally locked and all the enemies are stunned too. Metroid had 48 frames of invincibility for 0.8 seconds and also 8 stun frames for 0.13 seconds. The exact same as Legend of Zelda. Castlevania had a really long invincibility time, iframes 128 for 2.13 seconds. Stun frames was 51 for 0.85. And I remember playing like the original Castlevania, and it kind of felt sluggish to me. And I think it's because of that 0.85 stun time. Because whenever you get hit, that's a whole lot longer of being locked in without being able to move than like Zelda or Metroid or even Ninja Gaiden. So I think that you can actually feel the sluggishness when you make the stun frames too long. Mega Man 2, it had pretty lengthy invincibility iframes times, 2.25 seconds, and it also had half a second of stun time. So yeah, in Mega Man, I can't remember. I think they eventually fixed it in Mega Man, but that was the one of the games with the knockback, and you can get hit and then knocked off a platform, which feels really cheap. I think they fixed it in later Mega Man games. So if you're on a platform, you get hit, then you only get knocked back to the edge of the platform, which takes a little additional programming, but it doesn't feel as cheap. So being a math nerd, I went and took those values and ran some simple Excel statistics. So the minimum amount of time for invincibility was 0.8. We saw that with Zelda and Metroid. The maximum was 3.56, which we saw it in Super Mario 1. The average was 1.9 seconds of iframes, or 114 iframes, which about 2 seconds seems about right. And standard deviation was 1.03. So if you take your 2 seconds, don't go below 1 or above 3. That's kind of the standard deviation right there. Stay within that range. The stun frames, the minimum was 8. The max was 55 for 0.9 seconds. The average was 31 stun frames for just over a half second. And standard deviation, stun frames was 20. And the standard deviation for time was 0.3. So a good rule of thumb would be, I guess, half a second of stun. Don't go below 0.5 minus 0.3 is 0.2. Don't go below 0.2. And don't go above 0.8, just rounding those off. Here's some just brainstorming things. I thought I was going to have more for this, but some things I've never really seen much in games. But what would be cool is if you had a game and the regular enemies stunned you for a short period of time, but like the boss enemies stunned you for a little bit longer. Maybe some games have implemented this. I put the sprite of the Sledge Brother and Super Mario 3. I know like the Koopa Kids, some of them on the airships, whenever they bounced against the ground, you're kind of stun locked, but it really wasn't used for when you were hurt. But that's something to try. And maybe longer iframes for easier difficulty level. I think some of the later Mega Man games may have done that. Like you got easy mode, so you just increase the length of the iframes. So I got a demo. So I'll put the code for this out online. So I started out with just like a project using Mono Game again. No particular reason. Leave it as an exercise to the student to implement this like in SDL and Allegro and everything else. But I got a simple game here. Go ahead and start it first so everybody can see what it looks like. That's your standard mono game. So I got a character here. So this is no iframes at all. So it's really fast. So in this demo, you start out with 20 hit points. And this is no iframe. And I got it where you can move. So I got got the smiley face emoji. I took this from Open Emoji or Open something, free emoji. So I got the bad guy, angry face there. And then got the good guy. So you can see with no iframes, that health goes from 20 to 0 pretty darn quickly. So that's like every single update. Because whenever he collides, it's going to collide multiple times. They're going to intersect multiple times within that period. So yeah, you got to take this into account, or else your players are going to die very quickly. Just take a quick look at the code. I mean, I got the game manager right here. It's really simple. Just some simple graphics. Player pulled the input handler into its own class just so you can get that out of the main game. But yeah, this basically just handles the keyboard right there and tells the player to move up, down, left, or right, or whenever the keyboard to stop pressing in any of those directions. I got a player and an enemy, initial positions, got one texture list with the 3 textures. I got the smiley face emoji, got the angry face emoji for the enemy, and then the skull for whenever the player dies. Here's load content we're loading in, and this is all in the where was it? Content folder and content MGCB. This is the content manager for Monogame right here. So you just import your sprites and then create a sprite font for displaying the text. Got the update. Nothing special, just I created like a game object, kind of like in Unity class. So it just updates all the game objects, which is the player and the enemy. Then updates the keyboard handler right there. And then in the draw, it's just going to leap through all the game objects and call draw and pass in the sprite batch for those. And then draw a string showing the player's hit points right there. Looking at the game object right here, kind of modeled this after Unity, so just in a 2D fashion. So we got the X and Y position for the player, uh, width and a height, which I'm just leaving set to 64 unit size right there. An image, and really, if you were making a real game, this would be like a collection of images that you would probably loop through. Went ahead and gave them a name, and I don't think that's was really needed, but went and put a name in there because we're determining the object type by the class. Reference to the game manager, setting up the passed in values. The constructor right there had a set position call, so I can when I initialize everything, it can set their position. Update, leaving it to the subclasses. I didn't leave this as purely abstract. I made it virtual just so if the subclasses don't want to implement an update, they don't have to. So I just made it virtual. Draw is just going to draw the sprite at the X and Y position. Then I got our old, go back, I think it was 2 or 3 months ago when I did the 2D collision talk. Got our old 2D collision method right here, has collided. So that's going to tell if two game objects collide with each other, which I think is the more elegant way to do this. So this time I actually have a game object, then I have a player class and an enemy class, which both subclass game object. So what's neat about that is, like in the update, if the player is alive, then I can just say, for all the other objects, if the other object is an enemy, then just have I collided with that other game object? And if so, subtract off 1 health. Then if your health is less than 0, set is alive to false. And then change the image to the player dead image, which I'm just pulling directly from the textures dictionary that I defined in the main game manager class. Just have some balance checking just so the player can't move outside the window. And this right here should really be like an interface, but I didn't feel like making a whole interface for this. But that's what I would recommend doing. That way, in your input manager, you can just say, hey, if this game object implements, I don't know what you want to call this, a moving object interface, then move it. But right now I have it in the player class, which works for this simple demo. And yeah, by the way, I have is alive. So if the player's health drops to 0 or below, which shouldn't drop below 0. But if it reaches 0, then it's going to set is alive to false. Then it's not going to let the player move, or then it's going to stop checking collision and things like that. The enemy, so basically it has an X velocity in a lifetime. That's why I used to get that little. This isn't one of the behaviors that I talked about last month, but this is an example of like doing a sine wave, kind of like a projectile, using the lifetime. So the enemy is really not doing anything. The update, it's just going to move them left and right. Once it hits one side of the window, then it's going to start moving to the other side, back and forth. And then I'm just like taking this Y value, setting it to 200, then offsetting it by the sine of the lifetime times math times 2f. So that kind of makes it like based on seconds right there, I believe. I believe that's going to do for every second, it'll do 1 oscillation up and down. And then the 64 times 2f, that's just making it 2 units. It's going to go a maximum of 2 units. What is that? The peak amplitude and trough. It's been a while since I've done basic trig, but there are names for the parts of the sine wave. I just don't remember them off the top of my head. But yeah, that's what it does. So enemy really doesn't do anything. All the demo is just like doing the collision between the player and the enemy that moves on its own. That's basically it. There's the input handler. That's the one that I did last month, checking whether the keys pressed or lower, and this is like where it's calling player move left, stop moving left, move right, stop moving right, up, down, then capturing with the previous state, which a lot of other game frameworks handle this for you. That's why I wanted to pull this out of the game manager and put it in its own class. That way, maybe people can like just reuse this, not have to implement that in your main game logic every time. That's basically it. So the whole point of all that, again, just to look at it one more time, whenever the enemy collides with the player, their health's going to go down really fast, not giving the player a chance to escape or anything. Now, the next project, which I made these into separate projects, which if you're making a game, you probably won't want to do this, but I did this just so you could view the second state against the first state. You can do a diff or something and see what code has actually changed. I thought about like making a subclass of player called player with iframes or something like that. It's like, no, let's just make a separate project. That way you can diff and see the difference. So here's the player with iframes with invincibility time. So we added like the invincibility time float right there. I think that's basically it. We initialize invincibility time, float value, float number to 0. So here we added a little bit of additional logic. So if the player's alive, before we check for collision, we're going to see if invincibility time is less than or equal to 0. Shouldn't drop below 0, but floats can be weird. So I went ahead and made it less than or equal to 0. It might be minus 0.001 or something. So if the invincibility time is less than or equal to 0, then we're going to do our normal collision check. And then if it has collided with an enemy object, then we're going to subtract off 1 health point. Then also we're going to set the invincibility time to 2F, 2 float, which is 2 seconds. This really should probably be pulled out, made a constant or variable, class variable, something like that, instead of hard coding it right there. But this is a quick demo. So if the invincibility time is greater than 0, then in this else we're going to subtract off delta time from the invincibility time. And delta time is basically the game time, elapsed game time, total seconds. So this is equivalent in Unity's time delta time, or whatever it is. Just kind of converted the mono game format into a float variable called delta time. So it's just the amount of time as a float since the last update. That's basically all it is. So what I'm doing here is if the player is in iframes in invincibility time, then we're going to set the alpha to 0.2, which is a float value. And then we're going to override the default draw, and then we're going to draw it. And the only difference is if you look at game object draw, then we're going to draw the image with the rectangle of xy with width and height, and color white, which means like the original sprite color, no tinting or anything. So in this override draw, then we're going to draw it with the color 111, which is white, plus an alpha value of alpha, which we set to 0.2. And you could hard code to 0.2. I was kind of playing around with the different values right there. I had it at like 0.5. You couldn't really tell much of a difference. I mean, it just looked kind of faded, really, which I guess is what you're going after. But here's the demo. So here we're going to get hit. And there we go. He's faded for 2 seconds, and we went from health. You can see in the upper left-hand corner, went from 20 to 19. There we got hit again, 19 to 18. Then again, 18 to 17. So really, we could like turn down the maximum health to 6 or something, and you won't instantly die. So if we just keep getting hit, eventually, we will die. Again, I didn't implement stun lock in this, which I kind of tacked on when I was making the presentation slides, but I'll leave that as an exercise to the student right there. So yeah, that's basically all there is to it. Then I did another example. If you're really old school, if you're going for the old school effect and you want the flashing instead of the transparency. So the nice thing about transparency, if you got like a nice background with sprites and everything, that will look a lot better. I mean, it won't just look like a faded sprite. You know, you'll actually be able to see the background coming through. So this is the same thing, player class, except I modified the draw to use a boolean called isVisible. So by default, isVisible is going to be true. If invincibility time, if we are in iframes, if invincibility time is greater than 0f, then I created a new variable here called flash time. That's how long it's going to flash on or flash, like the old school 8-bit Nintendo Entertainment System games. So starting off, I had go ahead and uncomment this. I had a flash time of 0.5. So doing basic math here, if we got 2 seconds of invincibility time and our flash time is 0.5. See, 2 divided by half is going to be 4. So it's going to flash on and off 4 times, which means it's going to blink off 2 times. So that's what this flash count is. So I declared an int variable flash count. So basically all it's going to do, like I was just saying, take the invincibility time, divide by the flash time. So that's 2 divided by 0.5 is 4. There we go. So then we're going to take the flash count, whatever the current flash count is. So it's going to start at 4, go to 4 to 3 to 2 to 1 to 0. Then when you hit 0, then you're going to be out of iframes. So we're going to take a flash count mod by 2. So that's going to give us a value 0 or 1. So modulo basically divides that number 4, 3, 2, 1, or 0 by 2, by this 2, and give us the remainder. So it's either going to be a 0 or 1. So 3 divided by 2, or 3 mod 2 is 1, 2 mod 2 is 0, 1 mod 2 is 1, 0 mod 2 is 0. So you can see the 1, 0, 1, 0. So if it is 1, then we're going to set the isVisible to false. And I started out trying that with a, go ahead and play the demo here while I'm talking. So yeah, here it is, going to flash twice, off, on, off, on. Now we're out of iframes. Hit again, off, on. So not too interesting. Not something I've seen in a lot of games. Like some games may have had flashing that quickly, but usually not. But just for the demo, here's a 1/4 of a second of flashing. So yeah, a little bit faster. And the reason that I picked 1 for the mod value is because if you get hit and it's displayed, it looks like you're not getting hit. It looks like it's laggy. So on that first frame or first period, when you get hit, you want it to be off, then on, then off, then on. The only thing is it might be on at the end. Yeah. So there might be a little bit of part at the end when it's on and you're still invincible, which I think that's okay. I mean, I think that would be the reasonable thing to do. So here's 1/10 of a second of flash time. And you want these values to be somewhat... There we go. So that's something I'd see in an NES game, and you might not even be able to notice on the recording. But it's kind of like flashing on and off, 1/10 of a second. That looks pretty good right there. I'd use that in a game right there. And we're not even... I'll go in here and modify, just to show, like, set the HP to... I'll just go ahead and set it to 3. Now that we have the iframes invincibility implemented. So here, HP 3, we get hit. Then HP 2, we get hit again. And then 1, and he's running away from me, get hit, and now I'm dead. HP 0. I can't do anything. So the final interval right here is 0.05. This may be a little bit too quick. But yeah, like I was saying, you just want to kind of use nice even numbers. If you start doing like 3.14 or something, that looks pretty good too. I mean, the only problem if you get it too fast, if you put it at like 0.00001, then it's probably just going to stay on or stay off. I don't know. But yeah, you got to give it a little bit of time to turn on and off. But yeah, there I got hit, got killed. So yeah, that's basically it. Demos, presentation, nice quick presentation for this month. So appreciate everybody out there listening and watching, and yeah, I'll plan on being back in a month.